Okay, so now we're still in 8.2a, polygons, and we're going to do triangles. So every triangle has two names, like a first name and a last name. And one name for a triangle is about the sides, and one name is about the angles. Okay, so you just have to learn every triangle's first name and last name. So if we look at this triangle, you can see that all the angles on the inside are smaller than 90 degrees. And so we go, oh, we say it's acute because it's cute like a baby, small and cute. So when all the angles are smaller than 90, we call it acute. If there is a 90 degree inside that triangle, we call it the right angle. It's the right one to build a house with, because to build a house you need 90 degree angles or it would look funny. Okay? If you have one angle inside your triangle, doesn't matter which one, if you have one angle that's bigger than 90, okay, it's called obtuse. I always remember it because it's like a big person. Okay? Now, if we look at the angles, okay, if all the angles and all the sides are the same, they're all equal, we call it the equilateral triangle, because we have the word equal in it. If we have two sides that are the same size, or two angles that are the same, then it's isosceles. Like, I saw Muhammad, I saw Fahad, isosceles. And there's two S's, and that helps me remember that I have to have two angles and two sides that are the same. If you have two sides the same, then you're going to have two angles the same. And if you have two angles the same, you're going to have two sides the same. But if nothing is the same and everything is different, then it's not a special word, it's just called scaling. Okay? So let's look. Are the triangles acute, right, or obtuse, and why? So if I look at all these angles, they all look smaller than 90. But what does 90 degrees look like? Well, 90 degrees is like the corner of a piece of paper. So if we look here, there's 90 degrees, okay? I'm just coloring it for you so you can see it. So I can see that all of these angles are smaller than 90, so it's acute, like a little baby. So this one is called acute triangle. Now when I look at this one, this angle looks kind of big. And if I put that 90 degrees there, I can see that this angle here is a little bit bigger than 90. So if it's bigger than 90, I say you are obtuse, because it reminds me of a big person. Big, okay? Because that one. These are going to be acute, but that's okay. Those are small angles, but the whole triangle is going to be called obtuse because there is one obtuse angle in there. If I look at this, are all the angles smaller than 90? Those are smaller than 90. That's smaller than 90. Then all the angles are small, little, tiny, like a little cute baby. Like a cute baby, a cute baby, a cute triangle. If I look at these, they're all small, smaller than 90. So this one is also acute, like an acute, like a little cute baby. So, are all the triangles, are they equilateral? Equal. Are they isosceles? I saw Muhammad. This has two S's, so two sides have to be the same. Or scaling, everything is different. So here we can see all the angles are the same. They're equal, so it's an equilateral triangle. Here, let's see, this line is different. This has one line, 1, 2, 3. That means all these sides are different sizes. If I put two lines here and two lines here, that would mean they're the same size. But because they all have different numbers of lines on it, it means they're all different. So if everything's different, it's called scaling. Same question. Are the triangles equilateral, or isosceles, or scalene? Well, see, these have the same line on them. That means this and this are the same, and this are the same. So I have two sides that are the same. And so it's isosceles, because I remember, because there's two S's. So two sides have to be the same. So isosceles. I saw Muhammad. All the sides are the same and the angles are the same. They're all equal. So it's an equilateral triangle. One, two, 1, 2, 3. That means all of these are different. If all the sides are different, then all the angles are going to be different. So everything is different, so it's scalene. 4, 5, 6. All the sides are different, all the angles are different, so it's scalene. So now it says give each triangle two names, a first name and a last name. Okay, acute, right, or obtuse. Oh, look, it has a right angle in it, so this one is good for building things. It's the right one for building. Now I have to choose one from here. We have two angles that are the same and two sides are the same, so SS, isosceles. So this is an isosceles. So it's a right isosceles triangle because we have two sides the same and it's the right for building. 60, 80, 40, all different. 1, 2, 3, all the sides are different. So when everything's different, it's scalene. Now I have to pick something from here. Is there anything that's bigger than 90? 60, 80, 40, nope. They're all smaller than 90, so they're all like little cute babies. So acute. So it's a scalene acute triangle, or you can say acute scalene. It doesn't matter which one comes first. Look, they're all different. 40, 110, 30. 1, 1, 2, 1, 2, 3. So when they're all different, it's scalene. Now I check. Is there an angle that's bigger than 90? Yeah, this one here, he's kind of a big angle. He's 110. He's bigger than 90, so it's obtuse. Now remember, because it looks like a big person. Okay, obtuse. This triangle is called obtuse because it has one angle that's bigger than 90. Oh look, everything's the same. So if everything is the same, everything is equal. So it's called an equilateral triangle. Are all the angles smaller than 90? Yep, they're all acute. They're all little, acute like a baby. Oh look, 2 are the same, and 2 are the same. So isosceles. When 2 are the same, SS. Then I have to look at my angles. Is there any angle that's bigger than 90? Yep, this one here. It's 104. So it's bigger than 90, so it's going to be obtuse. The last one, everything looks different. So it's called scalene. And there's a right angle in there. That means it's the right one to build things with. That means the name is right. Okay.